Welcome back, Frank and friends. So I had a Magic Mirror project on my wall a few years back. It was based on the Raspberry Pi Zero 1.1. It had a slideshow for photographs and date and time, some news, calendar, that sort of thing. But I had another project that I needed the Pi Zero for, so the Magic Mirror came off the wall. Pi Zero went off and did its thing, and I don't even know where that project went. So a couple weeks ago, I decided that I wanted a wall clock on my office wall, and I started looking around, and I found a nice 7-segment LED clock, and it was like $35. And I said, you know, I've got these salvaged 24-inch displays that I'm not doing anything with. There's a picture of it here. Maybe I could put something together on that. So I tried to resurrect the Raspberry Pi Zero Magic Mirror project. And when I did that, it didn't fit anymore. So the Magic Mirror project has really grown, and it requires a desktop and a browser and a certain amount of oomph, that the Pi Zero no longer can accommodate the Magic Mirror project. So I thought, well, maybe I could write my own Magic Mirror project in Python. And I could not have a desktop. I could write directly to the frame buffer. And that began the new project that you're seeing today. So how about if I stop talking and demonstrate it for you? Welcome back, Frank and friends. So let's talk about the configuration of PyMirror. What you're seeing on the screen right now is PyMirror in debug mode. And so every module that's on the screen has a little white box around it, along with how much time it takes to run the module, the name of the module, and also its position on the screen. So now if for some reason things don't look the way you expect, you can turn on debug mode, and this is what you get to see. So what I'm going to do is remove all the modules, and then we'll simply add them back one at a time in order of complexity. So here we are with a blank screen because I've defined no modules. Let's just go through the config items. At the top there's debug, which we saw earlier. Secrets, this is a file that holds all your API keys, all your secrets. Force render, if you want the modules to be forced to render on every iteration as opposed to only when modules change. We'll talk about that later. You can force them all to redraw every time. What type of screen are you working with? Here, if you're running on the Raspberry Pi, this would say /dev/FP Zero. I happen to be running on my Mac, so instead of FP Zero, we're going to be writing to a file, and then the file is actually available through a website or a web server inside of PyMirror, and that's how you're actually getting to see the screen right now. Font name, this is the font for the entire system. If a module doesn't define its font, this is the font that will be used. The font size is the pitch of the font. The color and background color are the color of lines and background fill. And then text color and text background color when you're drawing text, and what the background for text would be. So that's the basic configuration of your screen. We can also specify that we want the screen rotated. So if you want to do a portrait mode, that would be possible. So a little bit different than Magic Mirror. The positions on the screen aren't predefined. You actually have to define them. None means that this is a position where some object that has no display would, or some module that has no display would be shown. Top strip is across the top. Alert strip, we'll talk about this. So top left is the upper left-hand corner of the screen. Top center left, top center right. All of these are defined as percentages of the entire screen. So top center right would be 55% X and 15% Y. So it's gone down 15%, and 66% to the right, and then 33% down. So you don't have to specify the pixel sizes. If for some reason you're using a different size display, the renderings will be proportionally correct. So again, different from Magic Mirror, these aren't predefined, and you define them here in the positions area. These things here, top strip, alert strip, and FPS strip, I've found that it might be useful to define positions by module as opposed to by position on the screen. And that's mainly because I found that some of these modules needed to move around. Just as an example, the alert strip, which is actually the middle of the screen here, is an overlay. It pops up on top of the rest of the display. So rather than trying to describe a position on the screen, the alert strip basically is where the alerts will pop up wherever this is defined. So I'm kind of moving towards having individual modules define where on the screen they live, rather than giving relative positions and having the modules then pick one of those relative positions. So down here are the module definitions. You can actually insert a full module definition here, and I'll do that as an example. Let's go get the text module, and all of these are stored in a folder called mod defs. So I want to put the word week up here because we're going to put the week of the month, and you should be able to just drag this in, copy this here, and drop it in here in modules. Okay, and we'll rerun this. So as you can see here, I've defined a module in place, so it's a text module. This is the simplest of all the modules. You can specify the module definition, and all of the modules have a generic set of options that belong to them, including the name of the module, its position on the screen, whatever font you want this module to use, and the size of the font. Now the text module, all of its configurations go into a separate dictionary called text, and we specify the text that we want to show on the screen, whether it's horizontally aligned to the left, the right, or center, and then vertically aligned. So this one is vertically aligned in the center, but it's a right justified piece of text. And you can see it here on the screen. Nothing interesting about this, except that now we're going to add the next module. But as we add modules, this file gets really complicated and large. So what I've done here is I've allowed us to specify the actual file that the module definition is in. So we don't have to have all this in the config file, and of course this works as expected. There you go. So now let's go to the next kind of the workhorse module, and that is the clock module. And what we'll do first is we'll put the time up on the screen in 7-segment format. So as you can see here, I've set up the time, and you can see it's popped up here using a 7-segment font. Let's take a look at the definition of the time module definition. So the first thing we have to define is which module we're going to be using, and it's the clock module. Remember, the clock module is kind of the workhorse of the system. It does all types of time-based displays. And as before, in this module definition, we've called it the time module. It has a text color of white and a text background color of null, which means it's going to be transparent background text. And we put its position in the top left, and we're using the 7-segment font as well as 128 points font size. Now down here is the date format, and this takes whatever string f time takes in the Python language. We've set it up with %i, %m, %s. We can modify this. I think it's %p will show us AM and PM. There you go. And because this is the 7-segment font, it does do well with a capital P. However, the letter M is a little funky, and that's one of the reasons I've decided not to display AM and PM on this particular module. Cool. So we've got the time up there. Now let's put the date up. And it's exactly the same module. We're going to use the clock module. We're going to put it on a different position, and we're going to use a different date format. So as you can see here, I've added the date module definition. And over here you can see here's the date in 7-segment format. Now mind you, debug is still turned on, so we're seeing these white boxes around each module's window. And there's the date, the title of the module, as well as its position on the screen. Now you notice that there's this little thing here, 0.00 seconds. This is how long it's taking to draw this on the screen. And currently, because we're being efficient with our pixels, we only redraw something if it's changed since the last iteration. And it hasn't changed, so it's taking 0 seconds to draw right now. So let's take a look at date.json. So this should look exactly like the time of day, except up here, of course, we've defined that we're using the module called clock. The name of this module on the screen is called date. It's in the top right using 7-segment font and 128 pixels. However, this time the date format is year, month, and date. So we get the date instead of the time. It's the exact same module, it's just got a different date format. So that leaves two other things that we want to put on the screen, one of them being the day of the week. So let's add the day of the week. So once again, day of the week, it's the clock module, it's got a name called day of the week. It's in the bottom center, and we're using a different font and font size, and then we're using %A for the date format, which happens to be the day of the week. So this is very, very simple. We're getting a lot of use out of this one module. We've got 4 different windows or modules on the screen, and yet we've only used one of the classes, which is the clock class. So finally, I want to put the week number on the screen. So let's add that. And there. So now our time and date part of our display is complete. Up here is the week of the year, and you can see here that comes from the week of the year module definition. And if we go to the week of the year module definition in JSON, exactly the same as the last ones. We're using the clock class, we're using the name of week of year. It's in the top center right. Notice I've got 4 segments up here, and it's putting it in the position to the right of the text. 7-segment font again, and the date format is %W. And as before, we have control over the H and the horizontal and the vertical alignment, so it's left aligned and vertically centered. So that covers the clock module, and we got a lot of use out of that. Now, Magic Mirror, which is really the reason why I'm doing this, I'm kind of trying to get Magic Mirror functionality on a smaller processor. It has the option to do an analog clock. If I remember, their analog clock is merged in with their date time module. And I found that cumbersome, so I made a whole other module just for the analog clock. Let's take a look at that. And there's my analog clock. As you can see, it's a pretty normal clock. It's a circle, and with the hours 1 through 12, and then a second hand that is animated, as well as hours and minutes. So this then has more options than the clock module. So let's go take a look at analog clock in JSON. So the module we're using is analog clock, and we've named the on-screen module analog clock. The color can be defined as being, if you're familiar with HTML colors using the hash tags, it's pound C0, C0, 00. So that's a type of red plus green would be yellow. You can also use the 3-character definition, so CC0 would have been just fine. Background color of black, text color of yellow, and text background color also of black. And the position on the screen is going to be the middle center, and we're going to use the original series of Star Trek title font at 48 pitch. Now down here, the analog clock has definitions for the colors for the hands. And if you don't specify one of these hands, like say, let's take out the second hand altogether and rerun, you'll see that it's a clock that has no second hand, no sweep second hand. So the color of the different hour, minute, and second hands defines whether or not it's on screen and the color that it displays at. So that's all of our date and time capabilities. It's a pretty simple definition. So now I'd like to move on to something a little more complicated. One of the things I noticed when I was building these modules, there's a certain amount of commonality between them, and I'll get into that in a minute, but we'll be moving into an area where we define a card for a module, and a card is just a rectangular region on the screen that has a header, a footer, and body text. That's a very versatile sub-module. We'll talk about sub-modules. But as I was developing this, I realized I could get a lot of functionality if I just was able to run Linux command line commands and display their output. And so the next option I'm going to show you is the CLI module. Okay, so I've added the fortune cookie module, and it uses the CLI class. And the CLI class will run a Linux command for you on a repeated basis, and it'll return whatever results you get back. We'll put it in your modules window. So let's go take a look at the fortune.json. So this is very similar to Magic Mirror's, hello there, sexy display, but instead of saying something, kind to you, what Fortune does is it runs the Linux fortune command, and the output from the fortune command shows up on the screen. And this runs once every 10 seconds. So here you can see that it's run the fortune command, and it says, you can't carve your way to success without cutting remarks. And then in a few seconds, it gets a new fortune cookie. So let's take a look at the JSON for this. Again, we're using the CLI module class. The name of this is going to be fortune cookies, and it's in the top strip. The command it's going to run is fortune. It's going to run that every 10 seconds. Now here, there's no header in this CLI. It's got a body that is equal to the standard out. Now, this is what's called templating. So if you're familiar with web development frameworks like React and Angular, you may be familiar with templating. And what we have here is what we want to be shown on the screen here. And we're just taking whatever the standard out is from this command and putting it on the display. And here is our card. And as I said before, there's a header and a footer, but we're not using those. So we define the text color to be 0cc, which is cyan, and a font size of 32. This is a very simple module, and it's very powerful. You could put anything in here you wanted, like, just as an example, you could do the Linux date command. You could do an ls command and have it show the results of the file system on your screen. Whatever you think you might want to be able to run. You could run like git commands to see if a project that you like in GitHub has been updated, and maybe you should go get it. So there are all kinds of things you can do by running CLI commands inside of PyMirror. So let's look at the next most complicated module, and that's going to be the news module. In fact, it's not really news, it's any web API. We'll take a look at that next. Okay, so I've added the news module, and as you can see over here, it has a header and a footer, and it has body text. So at the top here is a headline, and at the bottom is the byline. So this comes to us from CNN at, this next one comes from Wall Street Journal at July 10th at 7:38 p.m. This is actually in Universal Time Coordinates, Zulu time, Greenwich Mean Time, whatever you want to call it. So let's go take a look at the news JSON. Of course, it uses the Web API Module class. Down here is where we define all the details of a web API that we're going to call. And the first thing we have to define is a cache file. Now this is really important because when you make a call out to a web API, sometimes you get charged for that. A lot of web APIs have what's called a rate limit. You can only hit it so often. And as I was developing this, I was using the newsapi.org free API where I get 100 calls a day. And I quickly bumped into that limit because I was constantly restarting the PyMirror project. And so what I found was that if I first copied the output of the news API to a file, and then, as you can see, it's refreshing like every 10 seconds, just check that file to see if there was a cache file there. If the file was older than, say, 15 minutes, then I would just read from that file, especially if I was resetting, like Control-C and rerunning the PyMirror project. So that way it would always get the cached file instead of hitting the API. And if for some reason that was aged out, it would hit the API, copy the data to the cache file, and then we're in like Flynn. Cache timeout seconds, in this case it's 840 seconds, which is 14 minutes. So the cache will time out in 14 minutes and we'll get a fresh call from the news API. Updates minutes is 15, so every 15 minutes it's going to hit the API. Cycle seconds, every 15 seconds we see a news article, a new news article. And here's the URL for the news. And then down here are the parameters that we pass to the news article to get whatever news we're interested in. And in this case, we're going to pass it, once again, an API key. Now, I mentioned earlier the secrets file, and the secrets file is where you would store this news API key. And the other place you can put it is in your Linux environment variables. So anytime you see a $ with some text after it, that is a Linux environment variable that you can use and will be expanded. Now, the reason I did this is because I don't want to check my API keys into GitHub. That way, potentially everyone could see it. So I have a .secrets file, which is local to my environment. It's in my GitHub ignore, so it doesn't get checked in when I check in my code, and I can safely hide the API keys from the world. Let's see, other parameters are The country, page size is the maximum number of news articles we'll return, and the category that I'm interested in is general. And if you go to newsapi.org and you read the details for this API, you can see all the parameters that are available to you, and you would just stick them in here. Now, the last bit of this web API definition is the display, and what is it that we want to put on the screen. One thing that we can do is get the total, which is the total number of hits. We can get the maximum number of things that we want to display. So you may have noticed that I've specified a underbar and underbar here. And so this templated item is showing the index into the payload that we want to get out for the header. And inside of the web API class, there's a counter that goes from 0 to max, looking for any values that are inside the payload. And over here, you can see another template where it says payload.articles sub-n.title. And you'll have to look at the definition of the API to know what you want to put in your template. But for this news template, we always go to payload, which is the PyMirror variable that holds all of the responses coming back from your API. There's a dictionary, and in it there's an articles, and we can index it using underbar and underbar, and then suck out the title. So all of this then generates this title that's difficult to see because I've got debug turned on. So I'm going to turn debug off real quick. So now with debug turned off, you can see that the index here is 0. So this is the 0th article, and it will cycle through until it either runs out of articles or hits our maximum, which we specified as 10. So this is a pretty complicated way to get the news, but it's much easier than writing a news API or a news module that stands alone. So that means that if we can think about our APIs in a generic way, then we don't have to write a new module to hit an API and display its results. We can do it using the web API module. We also specified the body here, payload articles sub-n with .description, and then payload articles and source name. And then over here, we were able to use some of the Jinja templating to split out different parts of the date time that the article was published at. And it came with a letter T in the middle of the time, which is standard ISO format. So we split out on T, and then we also down here replaced the letter Z for Zulu with a blank character because we don't need to see Z at the end of the news article. So that is all of the display templating. Now down here, I've mentioned before that when we have something that's a card, it gets its own module definition dictionary. So we're defining the header, also the height in pixels of the header. Then down here is the footer with the font, and then in the middle is the body with its font, slightly larger font size. Text color is cyan, and then the background color is black. So that's the news module, the most complicated one we've looked yet. And now we're going to look at the weather module. So here's the weather module. It's pretty simple. It shows the title up here, the temperature, current temperature, the humidity, and the effective temperature, and then the date and time of the last measurement, which was today at 6 p.m. Looking at the module itself for weather, you can see here that the same module definition as before. Here's the URL for weather. Now notice that I didn't use the web API module class. I used the weather module class. And the reason for that is that when the weather information comes in, if there is an alert, we want to then send an alert to one of the other modules to let it know to display weather alerts. I'll show you that in a minute. Here's our cache file, which I've discussed before. As before, the cache timeout, the refresh in minutes, degrees. How do we want to display the degrees? Here in the United States, we use Fahrenheit. The rest of the world uses Celsius or centigrade. Our date time format, so the format of this down here is going to be %A for the day of the week, and then the hours, minutes, and seconds, and AM or PM. The latitude and longitude of the position that we're getting the weather from. So this is at my hometown here in Midlothian, Virginia, which is near Richmond. And then down here again is our API key with a $sign in front, indicating that it comes from our .secrets file. And finally, we are not interested in hourly or minutely updates. We are only interested in the current weather information, so we're not going to get like forecast information. Finally, we're using imperial units because in the United States, despite the rest of the world having moved on, we are not using the metric system, and we still all mainly speak English. So those are all the inputs to the weather API so that we can get from Open Weather Map our weather data. Now let's take a look at the card. Again, this is exactly the same definition that we used on the other two modules that used card format. We have a header, a body, and a footer with font size, text color, and background color. So there should be a lot of commonality here, so that once you learn how to use one of these modules and you find out that the next module has a card in it, you just put in the card definition and it should fit perfectly. So now that I've talked a little bit about weather alerts, let's talk about alerts. And I'll put in a weather alert on the screen, we'll see it. So now I've added a weather alert. And if you look at the weather alert, you can see that there's a heat advisory and it tells us what and where and when. And that it expires Tuesday at 8 p.m. Now, this is not something that I programmed in. This is coming from Open Weather Maps. And so we need to be able to capture that alert. And to do that, we have to define where that alert shows up. So we have an alert module. And I've defined it as being the weather alert. It's in the bottom left. And it is subscribing to weather alert events. And we use on PyMirror, we're using the publish and subscribe model, that a module that has something to share with the rest of the system will publish an event, and other parts of the system, other modules, will listen or subscribe to that event. And in this case, the weather module, this one here in yellow, is publishing weather alert events, and the alert is subscribing to those events. And so part of the weather module is that when it sees an event coming in through the web API, it formats it and then sends it to the weather alert, which is just of type alert class. So the header, the body, and the footer get some default text, and when the alert first shows up, it'll stay up for 10 seconds. In this case, 10 seconds. You could have a timeout to 0 if you wanted. But basically what this is doing is giving the alert a first set of text. And then the card down here is just like all the other cards, so font size, and background and foreground color. There's a header, a footer, and a body. And as you can see here, the header is red, the footer is white and with black text, and then the body is yellow text with a black background. So this is very, very simple in terms of its definition, but it's really powerful in terms of its capabilities. Now, we still have a need for one more module, and that's what do we do if there's a generalized alert of some sort. Maybe we want to create an alarm module, and we want an alert to pop up on the screen. So we can create a generalized alert, and I'll put that in next. So I've added the alert module to the module definition. Now I do want to point out that the modules are printed kind of in the reverse order in which they are listed here. So if you want a module to show up over the top of something else, it needs to be first in the list. So our alert.json goes here, and then down here you can look at the alert.json itself. As before, this is like other modules that have a card, and like the other alert module we were just looking at, it uses the module class. It's called alert. It goes in the alert strip, which happens to sit over the top of the week and the analog clock and the weather. So it kind of sits in the foreground. And then down here, we've got a header, body, and a footer. That's initial values, and then the card definition. So the card definition just gives it a header, body, and footer. And so I'll tell you what, I'm going to give you a little bit of foreshadowing. PyMirror has its own web interface. So you can send these events to our PyMirror. So here's our alert. We are sending an alert event, which our alert module is listening for. It's got a header of Waza, and then a body that warns Kayla that it's going to be hot today, and a footer that says stay safe. And this is going to time out after 6 seconds. So I send this command, and we go back and look at the display, you can see that our alert shows up, and after a mere 6 seconds, disappears. So that's our generic alert capability. That pretty much concludes all of the modules of interest. There are a handful of administrative modules. The last one I want to show you is the FPS module. FPS is for frames per second. So the FPS module falls into the category of like administrative or engineering software. And all it does is it shows a frames per second in the lower left-hand corner of the screen. And you can see here we're running on the Mac, so we're getting about 35, 38 frames per second. When we run on the Pi Zero 2, we get about 6 to 8, sometimes 10 frames per second, unless there's a lot of activity on the screen, and then it goes down to about 2 frames per second. As long as we can get to 1 frame per second, we will be in good shape, because this is a dashboard that basically shows date and time information. The rest of the display is actually pretty static. So now I kind of foreshadowed, I said that we have a web interface. So let's take a look at the web interface. So here's the home page for PyMirror. Mind you, now this would be running on my Raspberry Pi, and so the Pi is sharing this HTML page, and I can go to the control page, I can turn on debug, I can ask it to refresh the display and to do the remote display, which is actually what you've been looking at this whole time. So I'll send that, and if we go back, you can see the debug mode is now turned on. Let me see if I can just put these side by side. There we go. We can go back to the home page. We can go to send alert, and again send a new alert. Okay, if you wanted to, you can send this to weather alert event. Rain, more rain, and just send that, and that will end up down in our weather alert. And of course, if we sent it to just alert event, it would show up in our main alert box. So that is pretty much the capability. We can view the display, which we've been doing right along, back to home, and we can view any logs that are coming out in the backlog. So you can actually watch the logs. Turn off scrolling, clear the display, refresh the logs, go back home. So it's a very minimal web interface. It is not designed to give you the ability to run PyMirror on one machine and then display it on another one through a web browser. That's not its purpose. It's almost entirely for debugging. So keep that in mind. So I hope that you like this demo of the PyMirror project. Just some final thoughts, especially in comparison to Magic Mirror, which inspired this project. The colors are pretty garish, but that's a personal choice. I wanted to see the colors and get a sense of like how the bit mapping of the frame buffer was working, and if I was getting colorful display. So mission accomplished. Also, Magic Mirror is more for up close and personal, so you want more subdued colors. And PyMirror is more of a dashboard project. But you should be able to configure this any way you like. In fact, by the time you get this, there may actually be a PyMirror configuration that emulates what you get on PyMirror. It's slow. It's actually slower than PyMirror is, but it uses much fewer resources. It fits easily on a Pi Zero 1.1. I run it on a Pi Zero 2W, so I get the internet capabilities. It enters my mind that it could run on a Pi Pico. Probably, yeah, I think it might be able to run on a Pico. You could use the simple VGA or simple HDMI projects that I did earlier in the year, running MicroPython or CircuitPython with some tweaks. Yeah, I think you could probably fit this on a Raspberry Pi Pico. Again, it's not browser-based like Magic Mirror, so we lose features like layout and animation that we might get with CSS and JavaScript. But the bitmap graphics are easier to program and are, in a lot of ways, more reusable. It's a much simpler approach than Magic Mirror, so I think it's much easier to add new modules. No need to create CSS, HTML, and JavaScript just to get the time and date on the screen. And it's Python based, so I don't know, is that easier or harder than JavaScript? It was certainly easy to get started, I'll put it that way. Also, we have many fewer modules. There are no third-party modules yet because it's a new project. So if you're interested in writing modules, I'd be very interested to see what you come up with. And it's open source, so it's up on my GitHub, and it's still a work in progress. So by the time you see it and you see this video, things could have changed, and hopefully for the better. So I hope you enjoyed this new project, and as always, please don't like this video, don't subscribe to this channel, Don't look at my other channels or click here or there. Your time is precious, so please don't waste it on anything I'm doing. But as always, thank you so much for spending part of your time here with me, and I'll see you next time on Dr. Francintosh.